Hey everybody, this is TCG Productions here, and in today's video we are going to be tearing down this absolutely no good, no name piece of junk power supply that has a confirmed kill on this computer. And yes, it's still running. This video is being recorded immediately after the one that preceded this one. And if you want to look at it from the other way, this video immediately follows the previous video. So, yeah, this is a so-called ARC technology power supply, and this is the third one of these power supplies that I have had the misfortune of dealing with. So, yeah, these are no name, no good power supplies that are complete pieces of junk. And my first problem with these power supplies starts with the wiring harness. This wiring harness here is made of the thinnest wire that money can't buy. And it's exceptionally short too. So, it's exceptionally short too. Take a look at the 24-pin ATX connector, for example. This thing here, it might be 2 feet long if you stretch it hard enough. So, and the wire gauge is made of thin, and we'll be taking this apart. We'll be cutting this apart and seeing exactly what kind of wires in here. And they were so cheap that they didn't want to spend the extra 2.5 of a penny to give you a 3.3 volt wire on your SATA connectors. So, yeah, this power supply was original to the system that I just took this thing out of. And as we can see here, it's dusty. It is very dusty inside. This is far less than the amount of dust it had on it. Here we go. That's more representative of what it was actually like. So, but yeah, we're just gonna. But yeah, so we've got four screws here, and there's a little quality assurance label here, or warranty label here, that says this thing was manufactured in 2014, and I'm gonna guess May of 2014. So this thing has been around on this planet for 11 years, and 11 years and 8 months too many. So yeah, we're just gonna get right into it. We've got 4 screws here on the top, and then we'll be able to get into this thing, this pile of e-waste. I have not actually powered this thing up. We might do that later. We might do that later on in this video, outside from a safe distance. Might do that later on in this video, outside from a safe distance. And then the top comes off. And then, yeah, this is the thinnest, this is some of the thinnest, cheapest metal. I can just bend this thing up and around like a taco. Yeah, just like that. Just like that. Now it's at an easy flat pack form. Now it's in a convenient flat pack format for easy disposal. Yeah, get a good look at that label. We'll make that the video thumbnail. So, yeah, we'll make that the video thumbnail. So, now we are into the power supply. And this thing is loaded with dust bunnies. A copious quantity of dust bunnies at that. And, yeah. So, first thing I noticed straight away is that this thing has no radio or electromagnetic suppression hardware on it at all whatsoever. We go from the power plug straight to the power switch and straight into the rest of the power supply. And if we look over here on the other side of the power, supply, well, if we look down here in the middle, we can see there's pads and stuff for stuff like, yeah, for capacitors, chokes, stuff like that, stuff that helps suppress EMI and RFI. There is nothing there. The only thing that's there is a fuse. And from that fuse, we go through four diodes here, forming a full wave bridge rectifier, and then straight into our boost and filtering, capacitors here. And then these two orange wires go to our voltage selection switch, which enables or disables the 400 volt boost capacitors here. And if you're on a 115 volt line, this switch will enable those. If you're on a 230 volt AC line, this switch will disable those. Now, if you are on a 230 volt line and you enable this, you'll let the magic blue smoke out. And that would honestly be the preferred option for this power supply. Let the smoke out of it without it being attached to a computer. Then we have the thinnest heat sinks. Oh wow. Yeah, those are thin. I should not be able to do that. Yeah, I think I just ripped the solder joint. I think I just ripped the solder joints loose on those chopper transistors there. Yeah. And then we have three transformers. We got an ERI 35 size transformer. We have, that's so dusty I can't read it without getting the dust off. Then we have an EE19, and then we have an EE16 transformer down in there. Obviously this one's going to be for our 12 volt rail, and then the other two are going to be for our 5 and 3.3 volt rails, more than likely. Then we have another big heat sink here, and oh wow, yeah, this thing is assembled with the finest quality garbage. I shouldn't be able to do that, but I am. And then on this, we have our three rectifiers. We've got one for 12, one for 5, and one for our 3.3 volt rail. And then, yeah. And let's see. The PCB is silkscreen, is being manufactured 18th week of 2014. You know what? I'm gonna zoom this thing out. Let's get this power supply wiring. Let's get this wiring harness out of the way. Where's my cutters? Let's get this wiring harness just cut loose and out of the way here. So, cut our 3.3 volt wires loose. The fan is probably the only semi-good part about this. We've got our minus 12 volt and our PS on wires. And we've got our 12 volt wiring. And these are all just coming free so easily. Another 12 volt wire right down there. And then we've got a big cluster of ground wires. Back here. And then we've got a cluster of red 5 volt wires. One left. And we have a brown wire back here, which I think is going to be a sense wire. Either that or power good. So, yeah. This wiring harness probably, I don't even think this wiring harness in its entirety weighs, I don't even think it weighs half a pound. It's tiny in terms of weight. And it looks like it's made with aluminum wire. We'll confirm that here in a bit. But over here, there goes that. Nothing of value was lost. I'm surprised all the capacitors are still good. At least visibly, they're not bloated or anything like that, spilling their electrolyte everywhere. We've got, looks like a couple of inductors or chokes. We have our capacitors. We have our 3 rectifiers. Then we've got some transistors. And whatnot. And then we have our little cheap and cheerful controller IC, which is upside down. It is a well trend, and I cannot read the IC number on the camera's viewfinder. I will try to get a picture of this. Okay, it is a well trend WT7520. So I'll look that up and see what this thing's capabilities are. And I'll look that up, see what this thing's capabilities are, and go from there. But yeah, we've got a... I'm surprised the fan in this thing still rotates at all. But I can feel the bearing is rattling around in there, so the fan's not even good. There's just nothing good left in this power supply. So I'll go ahead and cut the wiring out for the boost capacitors. And then, oh wow, whoa, that's awful. We'll have a look at the AC input wiring. It's tiny. The AC input wiring is very tiny. So I'm gonna cut this AC input wiring out. Have a ground wire that is not, we have a ground wire here that is not screwed down. It is instead hard soldered. So, snip. And then 4 screws will get this, 4 screws will get the PCB out of here. Yep, I've got, oh my, that is not great soldering work on the bottom. So here's the bottom of the PCB. We've got our input side over here, and we've got our output side over here. So just looking at the output side, yeah, I guess the soldering is okay. But flexing around the heat sinks pulled the mounts loose on the bottom of the PCB here. I'll flex the heat sink, and you can see one of those joints wiggling around. And then I'll flex the other heat sink on the secondary side. And well, I can't. There we go. See, I'm trying to find it on the camera's viewfinder. There we go. Yeah. Well, yeah, we have a pretty cheap and nasty little PCB here. With no quality to speak of. And then got some capacitors right here. They couldn't even be bothered to apply the glue correctly. And it obviously goes without saying, do not poke around in one of these power supplies if you don't know exactly what you're doing, because these things have dangerous voltages and can really turn your day upside down in a bad way if you get on the bad side of one of these things. This power supply has been sitting unplugged since as long as I can remember. But yeah. But as we can, if we have a look right here on the PCB, we can see that the PCB started to turn brown right in there from the amount of heat those diodes have been putting off, which means those diodes are not very, which means they're probably running those diodes right at their limit. And the brownage on the PCB continues around the primary side chopper transistors. So those transistors were probably running right at their limits or very close to them as well. It also means that this power supply didn't have near enough the amount of airflow required to keep everything cool. This power supply probably ran miserably hot. So, the rest of the PCB doesn't look like it's been grossly overheated or anything, but there is, once again, a noted lack of quality. We have some capacitors here that are branded TMX. AirAsia X. You probably shouldn't Google that. TMX, again, no-name Chinese brands. I'm shocked these capacitors are still good after all these years. Here we go. We have another capacitor right in here. Put my finger on it. What is it? JD? JP? JFP? JFD? I don't know. Some brand I've never heard of before. And then we have TS, another capacitor brand. 470 microfarad, 200 volts. 200 volts, wow. So, on a typical 120 volt, on a typical 120 volt AC line, those things would be right up against their voltage limits anyways, because that's 120 volts RMS, but probably around 140, 150 volts. I'll look it up and paste it into the video here. Peak to peak. So, yeah. Now, for our capacitors. Now for our wiring. We'll start with what we have in front of us right here, right now, which is the wires going to the capacitors here. The wires that connected the boost filter capacitors, the PFC capacitors, to the voltage selection switch. Strip this back. And it looks like copper. Yeah, it looks like copper. It is very, very flexible. And it is very, very flexible though. And I wouldn't doubt I wouldn't be surprised if this was copper clad aluminum. Ow. Copper clad aluminum. And a little strand just poked me. So if we take our wire strippers here and kind of scrape away at this. Yeah, it's super flexible. So I wouldn't doubt this being copper clad aluminum. I could do a flame test and see if the copper coating, see if there's a copper coating on here that just burns off. But if we look real closely at the edges here where it's broken, where some of the strands are broken, they almost have an aluminum. They almost have like an aluminum sheen to them. So, yeah, probably copper clad aluminum if I had to guess. There's more bulk to the insulation than there is to the wire. There's more bulk to the insulation than there is to the wire itself. Also, wouldn't doubt that this insulation probably does not have any kind of a fire retardant in it. So we'll cut a little section off there just to expose some fresh wire. And then we'll strip this using the 16 gauge setting. So yeah, the actual copper inside, the actual wire inside is only 16 gauge, but the insulation that they have on it makes it look like it's 12 gauge wire. And let's see, there's no, yeah, this says from what I can read on the wire itself, it says 600 volts, 20 gauge. So, oh yeah, I was looking at the wrong side of my wire cutters, my wire strippers here, because we have wire gauge solid and wire gauge stranded. So yeah, it's 18 to 20 gauge wire. In fact, if I put this in the 20 gauge hole, I still have room to move it around. And this stuff is just the thinnest, junk money can't buy. Fold it over like that. Move it around. So, yeah. And then, if you want to see a real work of quality here, this is one of the input connection. This is a neutral connection. Now, notice how this neutral connection here is still on a black wire. That's obviously not correct, and it looks like it's 20 or 22 gauge wire. So we'll strip a length of this back. We'll strip a length of that back, splay out some of the strands. Again, incredibly flexible. There's almost no resistance to this at all. And speaking of resistance, what I'm going to do here is I'm going to cut this off of the plug there. I'm going to cut the end off there, get some fresh wire going here, and I'm going to take a multimeter and measure the electrical resistance of this wire in ohms. And measure the electrical resistance of the wire in ohms. So we'll set this to ohms. Set that right there. Zoom in on that real good. I'll take one of my meter leads and take the safety covers off the meter probes since we're not working with anything live. And I'll measure from one very end of the wire to the other very end of the wire. And it's saying effectively a dead short. 0 ohms. So we'll manually range this down to individual ohms. Yeah. So just as a reference, I'll touch the meter leads straight together. So yeah, I see no printing of any kind on this wire. So now we'll have a look at the our wiring harness. There's a zip tie on the end here that I need to cut loose. So we'll use we'll zoom this out. So this is our 4-pin CPU. This is our 4-pin CPU power connector right here, and it's in total length going back to the power supply. So what I'll do is I'll strip the ends off of those. Well, the first thing I'll do is I'll go ahead and cut all these wires off back here. And then I'll strip these wires back, see what kind of wire gauge we're working with here. Okay, that's going to be 20, 20. Yeah, all of these are 20 gauge. It looks like copper. It looks like copper on the end here. So what I'll do is I will measure the electrical resistance of both of the 12-volt wires. We'll measure the electrical resistance both of each of the wires here to the connector. So I'll just pick one of the 12-volt wires at random and measure to the connector. And it's giving us a reading of about 0.1 of an ohm. Varies. So who knows, maybe we did get lucky. Maybe this is actually copper wire. It's very thin copper wire. And yeah, 300 volt 20 gauge. So yeah, 20 gauge wire is just nasty stuff. I personally, I don't run a power supply in a computer. I don't run a power supply in a computer where the wiring is not made of at least probably 16 gauge wire minimum. So that's showing 0 ohms. Now we'll do one of the ground wires. 0.1 ohm. .1. Okay. So yeah, well, everything in this power supply is made of 20 gauge wiring, at least all the stuff that matters. So, yeah. So let's assume a standard 80% efficiency. I don't even know. Yeah, the cover is on the floor somewhere. So let's just do a little bit of math here. So say we've got 500 watts, and yeah, say let's be charitable to this thing a little bit and assume it can actually deliver its full 500 watts of rated load. But we're doing so at say let's say 75% efficiency. Is that right? 875 watts? Yeah, let's just assume. Yeah, so let's see, 500 watts. Let's assume 80% efficiency. So say we're pulling 625 watts at the wall. Divide that by 120 volt line. Nominally, we're going to be pulling about 5.2 amps through that tiny little AC input wiring. And so let's see, 20 gauge stranded. And depending on how you look at it, it's either going to be 11 amps for chassis wiring or an amp and a half for power transmission. So it'll probably handle it. It's going to get uncomfortably hot pushing 5 amps through it. So yeah, I don't even want to use the wiring off of this. I don't even want to use the wiring off of this thing because it's all made of the same garbage. And this PCB here, there's no filtering, no input filtering, so you're going to be spewing the airwaves with copious quantities of EMI and RFI, and radio DXers and ham radio operators are going to hate you if you make the unfortunate mistake of plugging one of these things into power and turning it on. There's probably no protections fitted on this thing, so if this thing goes boom, it's going to take your computer down with it. Yeah, if this thing goes boom, it's going to take your computer down with it. The components are under spec. The components are under spec. The wattage is overrated, and this thing is going to be unstable, pushing anything close to its rated load. And I bet you this thing was sending tons of noise down its output rails. It was already unstable, and then something happened, like a power outage or a power blip or something like that, and it just sent a voltage spike to the motherboard, probably on its 3.3 volt rail, if I had to guess, going by how the system was acting and what was dead and what wasn't dead in the previous video, and it just cooked the system. Took the south bridge down, took the USB controller down, and yeah, that was it. System ended up comatose and got junked. So, anyways, that I believe is going to be the end of this video. So, anyways, this is TCG Productions. Peace out, guys. Peace out. Do not buy cheap, no-name, low-quality power supplies for your computers. Spend the 40 bucks and get something made of actual quality, not Chinesium, and it'll save your computer. So anyways, peace out, guys. Peace out. And I'll see you in the next one.